It did. Okay, this is the review for the midterm. I don't have enough room to include the data on the screen you're going to see, but everyone should have a practice midterm with them at home. So we're going to start with number 1, and we're going to do part E first, because that makes the most sense, and you'll see why in a minute. So we're going to create the stem plot. And the left side is the stem, and the left side is called the leaves. And when we look at our data, we see that our data goes from a low of 65 to a high of 97. So we have numbers in the 60s, 70s, 80s, and 90s. So for the stem, we're going to say 6, 7, 8. Let me erase that, make it a little bit better. 8, 8, and then 9. Okay, looking at the data, the first number is 88. So we're going to go on the line for 8 and put an 8. The next one is 93, 97, 79, another 93, 65, 80, 89, 79, and 82. That's the first row. The next one is 86, 78, 96, 91, 88, 81, 87, 70, 68, and the last one is 90. But that is the scratch copy. The final copy is going to put the numbers in order. Stem and leaves, we've got 6, 7, 8, and 9. And so the 60s already are in order, a 5 and an 8. The 70s would be 0, 8, 9, 9. The 80s would be 0, 1, 2, 6, 7, 8, 8, 9. And then for the 90s, it's 0, 1, 3, 3, 6, and 7. So that is the final stem plot. The reason we do the stem plot first is it helps us with part A, because we can see by looking at the stem plot that there are 2 numbers in the 60s, there are 4 numbers in the 70s, there are 8 numbers in the 80s, and there are 6 numbers in the 90s. So so now we will go do part A. Number 1 still, but this is part A. And again, we start with what I call a T-table. The left side is the class, and the right side will be the frequency. And I said that we're going to have 4 classes, and the first class is 60 to 69. So 60 to 69 is the first class, 70 to 79, 80 to 89, and 90 to 99. And because we did the stem plot first, we've already figured out that there are 2 numbers in the 60s, 4 numbers in the 70s, 8 numbers in the 80s, and 6 numbers in the 90s. And to check and make sure you got all of them, you can add all this up, and it does add up to 20, and you were given 20 numbers, so that is a check. Okay, now for part B, we need the relative frequency. So the left side is still class, but the right side is called relative frequency. And the left side is the same as part A. It's 60 to 69, 70 to 79, 80 to 89, and 90 to 99. To find the relative frequency, I'm going to do the scratch work over to the side here. You need to divide, and you need to divide each class frequency by the total of all frequencies. So the first class frequency is 2, and we're going to divide that by 20. And that comes out to be, so 2 divided by 20 comes out to be 0.1. I just went to 2 decimal places here. So we're going to call that 0.10. If you have a lot of rounding to do, 3 decimal places are better, but this one comes out nice and even because of the 20 in the denominator. Okay, the next class frequency is 4, and 4 divided by 20 would be 0.2 or 0.20. The next one is 8 divided by 20, which turns out to be 0.4 or 0.40. And then the very last one is 6 divided by 20, which turns out to be 0.3. But I'm throwing 1 extra zeros on here. To check and make sure you have the relative frequency correct, you want to add all this up, and it adds up to 1.00, so you know that you have. Okay, so now we're going to do 1C, which is the cumulative frequency table. The left side is still class, but the right side, that's a crappy line, but we'll live with it, is cumulative frequency. And we'll do the scratch work over to the right. And when we start cumulative frequency, you always start with 0. So when you come into this world, you have 0. And cumulative means to add. So what we're going to do is we're going to add 2, which is the class frequency for the first class, plus 2. So that's going to give us a total of 2. Then we're going to take the 2 we already have, and we're going to add the next class frequency, which is 4. And that's going to give us a 6. And then we're going to take that 6, and we're going to add the next class frequency, which is 8. And 6 plus 8 would be 14. And then we're going to take that 14, and we're going to add the last class frequency, which is 6. And that totals 20. And that is our check, because the last number should be the total number of pieces of data, which is 20. Now, the left side here is a little bit trickier, because we use either the phrase or the symbol for less than. I'm going to use the symbol for less than. And if you go back to Part A and you look at that frequency table, you can see that the first 2 numbers, or even if you look at the stem plot, the first 2 numbers are in the 60s. And they could be, if you look at Part A, as high as 69. But what we know for sure is those first 2 numbers are definitely less than 70. And the first 6 numbers are definitely less than 80, and then less than 90, and then all 20 numbers are less than 100. Okay, let's do Part D, and we'll be done with number 1. And Part D is to make the histogram. The histogram is a graph, that's going to have a vertical and a horizontal axis. Along the horizontal axis, we use class boundaries. Class boundaries are the numbers halfway between the ending of one class and the beginning of the next class. So again, going back to part A, which is what we base all of this off of, the first class ends at 69, and the next class starts at 70. So the point midway between 69 and 70 would be 69.5. But that is, in fact, the second class boundary. And then the next one would be 79.5, and then 89.5, and then 99.5. But we need a beginning class boundary, so looking at the pattern, you can see that the first class boundary has to be 59.5. I didn't tell you what this data represents, so you can't label it with anything, maybe just class. The vertical scale is going to represent frequencies. And the vertical scale must always start at 0. And you can use increments of whatever you want. If your numbers were high, you might use increments of 10 or 20. But our highest frequency is 8, so I'm just going to count by 2s. So 2, 4, 6, 8. So really, for what you do, you want to count either by 1s or 2s. Okay, since the first frequency is 2, the first bar is going to go up to 2. The next bar goes up to 4. And the next one goes all the way up to 8. If you have lined paper, it comes out a little better because you've got lines to use. That was a little off, but we'll pretend. And then the last one is 6. And that was a little over. It probably doesn't look too good on the screen, but close enough. And then you're supposed to shade in the bars. So you can do whatever kind of shading you want. Some students bring colored pencils. And this one I'll go diagonally. And this one will go horizontally. So there is your histogram. And by the way, there's no problem with starting the horizontal scale at 59.5. It's only the vertical scale that has to absolutely start at 0. Okay, so that's it for number 1. We'll move on to number 2. Okay, so moving on to number 2. Again, I have the data on the left board. And oops, let me get the correct marker here. The first question for number 2 is to find the mean. Part A, the mean. And the formula for the symbol is x bar. And the formula is the sum of the x's divided by n. And another word for the mean is the average. So what you need to do is add all of the numbers up, and they add up to 513, and you divide by the number of values, which is 9, and so the mean is 57. The second question asks you to find the median, and to find the median, you have to first put the numbers in order. The symbol for median is x with a tilde. So the numbers in order are 49, 52, 52, 52, 55, 57. Oops, there's two 55s. Hold on a second. Okay, so 55 and 55, and then 57, and then 67, and the last one is 74. So the median is the number in the middle, and so that would be 55. There are 4 numbers below it and 4 numbers above that. So the median is 55. Part C asks you to find the mode. And the mode is the value that occurs most frequently. If no number is repeated, the answer is no mode. But we have numbers repeated here. We have 2 55s, but we have 3 52s. So the mode is 52. Part D is the mid-range. And the mid-range formula is not on the formula card, so you need to memorize this one. And the formula is the high plus the low divided by 2. And we just had the numbers in order for the median. So the high is 74, the low is 49. You add those 2 numbers together and you divide by 2, and the mid-range turns out to be 61.5. Those first 4 are all measures of center, and they're supposed to be kind of in the vicinity of each other. So 57, 55, 52, and 61 are kind of in the vicinity. Okay, now we move on to measures of variation, and the first measure of variation is the range. And that's another formula that is not on the formula card, so you need to memorize it. And the formula for the range is the high minus the low. We know that the high is 74 and the low is 49, and so the range turns out to be 25. And that's not in the vicinity of the other numbers because it's not a measure of center. Okay, part F is to find the variance. But before we can find the variance, we need to have some other numbers. And so I'm going to list our data over here. Our data is X, and it doesn't matter whether they're in order or not in order. It's 49, 50, I'm going to do it like it is on the answer key. 52, 52, 74, 67, 55, 55, 52, and 57. Okay, we already know from part A that the total of those numbers is 513. What we have to do now is take each of those numbers individually and square them. So 49 squared is 2401, 52 is 2704, and that's twice. 74 is 5476. 67 is 4489. 55 is 3025, and we have 2 of those. 52 is another 2704, and 57 is 3249. And then you have to add that column up, and that adds up to 29,777. Now, you don't actually have to do that by hand. I did it in case some people want to do it that way, but if you have a TI calculator, you can just put the original data in list 1. It's stat, enter, and then put the data in list 1. And when you're all done, you hit stat again, you arrow over to calc, and then it's usually enter, enter. Some of the calculators, it's enter, and then scroll down to calculate. But those will give you those numbers. You don't have to do that by hand. Okay, the formula for the variance, this is part F. The variance, and the formula is, well, the symbol is S squared, and the formula is n times the sum of the x squareds minus the sum of the x's squared over n times n minus 1. I'm going to fix this 2 up here. It's not on the formula card called variance. It's called standard deviation shortcut, and you just remove the square root sign, and then you have the formula for variance. Okay, so let's plug the numbers in. So n is 9, we know that. So it's 9 times the sum of the x squareds, and the sum of the x squareds is 29,777, and the sum of the x's is 513. So now we need 29,777 minus 513 squared, and that's all divided by 9 times 9 minus 1. You shouldn't show every single little step. I don't want to know what 513 squared is, but let's condense the numerator down into one number. So it's 9 times 29,777 minus 513 squared. And that turns out to be 4824. In the denominator, 9 minus 1 is 8, so it's 9 times 8, which is 72. And then 4824 divided by 72 comes out to be 67. So the variance is 67. I'm going to squeeze in here G. G asks you to find the standard deviation, which is S. And S is equal to the square root of S squared. Or the standard deviation is equal to the square root of the variance. So it's the square root of 67, which turns out to be 8.185352772. It continues on. And I do not care how many places you round to, but you need to round correctly. The general rule of thumb in the textbook is to round to one more decimal place than the original data. So since the original data was whole numbers, I'm going to round to one decimal place and call this 8.2. Okay, and one more comment. The top of my G is missing for some reason. If, when finding the variance, this one came out even to an even number, 67, but if it's not an even number and you round it, when you go down to calculate the standard deviation, do not use the rounded number. You have to use the original number, because I will take off a point if you use the rounded number. Okay. Okay, we're up to problem 2H. And 2H asks you to find the percentile, so this is still 2H, the percentile corresponding to 62. Okay, on the answer key there's the long version of the formula. But there's both the long and the short. I'm just going to start with the short version. And basically it says that the percentile of 62 is equal to the number of values less than 62 divided by n times 100. When we found the median a little while ago, we put the data in order. And it turns out that 7 of the numbers are less than 62. There's only 2 numbers that are higher than 62, and that's the 67 and the 74. So the numerator here is 7, the denominator is 9, and you have to multiply that by 100. So when you multiply that out, it's the 77.777. And with percentiles, we generally round to a whole number. It makes sense. And we round correctly on this problem. So 77.7 would round to 78. So you can write the answer as the 78th percentile. Or you can use percentile notation, which is just big P sub 78. And we rounded that up because the number after the decimal point was a 7. Okay, going on to part I. Part I asks you to find Q1. Okay, just to remind you, the formula, oh, look at how the word percentile came out crappy at the beginning. Anyway, that formula for percentile is not on the formula card, so you need to memorize it. Okay, so Q1 we have to convert to percentiles. The conversion is in the margin on page 117 in your textbook. But Q1 is P25. And the way that I like to remember that is that 1/4 is 25 pennies. Q2 is P50, and Q3 is P75. Okay, in order to do this one, we're going to have to calculate the locator L. And the formula for the locator L is K over 100 times N. And that one also has to be memorized because it's not on the formula card. It's similar to the other formula. They both have 100 and an N in them, but the 100 and N are switched. Okay, K is defined as the percentile in the question. So since we have P25, that tells us that K is 25. So this is going to be 25 over 100 times 9. And when you multiply that, you're going to get 2.25. 2.25. And this is strange, but this is the way the author does it. You're going to take that number and you're going to round up. So it's going to round up to the third number. And it's only when you're finding the locator L that you round up. Otherwise, you do normal rounding every place else. So what they're telling us is that Q1 is the third number when the numbers have been put in order. And we did that again for the median a little while ago. And so the third number is 52. So Q1 is equal to 52. Okay. Okay, so now we're up to part I, which is the box plot. Oh, no, J, right. It's number 2, part J, which is the box plot. And in order to make a box plot, you need a 5-number summary. And the 5 numbers that you need are the low, Q1, the median, Q3, and the high. And we already know a bunch of these numbers. We know that the low is 49. We know that Q1 is 52. We just did that one. And we know that the median is 55. And we know that the high is 74. So we would have to find Q3. But I'm going to give you a shortcut for Q3. When we found Q1, we said it was the third number on the list. So to find Q3, you can go to the end and count backwards, and it's the third number in the backwards direction. So it turns out that Q3 is 57. Okay, and now you have to draw the ruler for the box plot. And the ruler is going to go from 40 to 80. And on the midterm, I generally tell you how to draw the ruler from what to what. So this one is going to go from 40 to 80. Most of the times you need a number smaller than the lowest and a number higher than the highest. But this works really well because as human beings, we're not machines, but we can divide things in half pretty well. So I'm going to find the middle, approximately, and what would be in the middle with 40 and 80 would be 60. And then I'm going to divide each of those pieces in half as best we can. So that's 50 over there and about 70 over here. And now I'm going to divide those in half, but I'm not going to put the numbers below it because it would just get too crowded. So I'm just going to divide it in half. So that's 45. This is 55. This would be 65. And this will be 75. And then you're going to go back and put... Okay, so to construct the box plot, first we're going to go to the... Oh, wait a minute, we didn't finish the ruler. I forgot. Okay, now what we want to put is 4 evenly spaced little lines between the big lines. I mean, it's not going to be perfect, but you want to try and make it as best you can. And the last one. Okay, so 49 is about right here. You put a little line and you put 49 above it. And then you go to the high, which is 74, which would be about right here. Hope I lined those up well. And then you connect those two. And that is the beginning of the box plot. The box plot cannot be connected to the ruler. There's got to be space in between them. And now the 3 middle numbers are going to form the actual box. So, and you make these lines a little bit longer. So that's about 52. The next one is 55. And then the last one is 57. And then you connect the 3 lines on the top and the bottom. And so this is 52. This is 57. And since it's a little scrunched in here, I'm just going to put a little arrow for the 55. But that is the box plot, and the only numbers that you should write on the box plot are the 5 numbers in the 5-number summary. Okay. Let's go on to problem number 3. Problem number 3 asks us to find the mean of the frequency table. So first I'm going to copy down the table. The left side is class, and now we started to use little f for frequency. And the classes go 0 to 4, 5 to 9, 10 to 14, 15 to 19, and then the last one is 20 to 24. And the frequencies are 2, 4, 7, 6, and 3. One of the problems with the frequency table is that you don't know all the original data. So we know that there are 2 numbers somewhere in the range of 0 to 4, but we don't know what they are. And so in that case, you want to, here, I'll do it down here, I think it'll fit. 0, 1, 2, 3, or 4. It could be any of those numbers. We don't know, so we're going to guess. And the best thing to guess is the number in the middle, which is called the class midpoint. And so the first class and we call them X, so I'm going to add a column here called X. So the first class midpoint is 2. And the next one would be 7. But you might want to observe that the class width is 5. The class width, remember, is the difference between any two consecutive lower class limits or any two consecutive upper class limits. So once we know that the class width is 5, we can just add 5 each time. So 2 plus 5 is 7, 7 plus 5 is 12, the next one is 17, and the last one is 22. And we need one more column, and the last column is called F times X, which means you have to multiply each F number by each X number. And 2 times 2 is 4, the next one's 28, and then 7 times 12 is 84, 6 times 17 is 102, and 3 times 22 is 66. The formula for the mean of a frequency table, mean frequency table, is on the formula card. It is the second formula on the formula card. And for the first time ever, he used the right notation here, so this is good news. The formula is X bar is equal to, oh, I don't like the way that my equal sign looks. Let me fix that a little bit. Is equal to, when it's a fraction, the numerator is the sum of, and then parentheses, F times X, and the denominator is the sum of the F's. So what we need to do is add up the F times X column, which is the last one we did, and that adds up to 284. And then we also have to add up the F column, and that adds up to 22. So we come back here to our fraction, and our numerator is 284, and our denominator is 22. And when we divide that, it turns out to be 12.9090 ... which we would probably just round to 12.9. Remember, I don't care how many places you round to as long as you round correctly. Okay, so that takes care of question number 3. Let's go on to question number 4. Just to remind you, question 1 is from chapter 2, and questions 2 and 3 are from chapter 3. Number 4 is from chapter 5. It's a little bit out of order, but that's how it worked out on the page. So question number 4 comes from chapter 5. But this is number 4. Let's write down the information. In Hidalgo County, Texas, 80% of those eligible for jury duty were Mexican Americans. So that 80% is going to be our P, or probability. So P is equal to 80%, which would be equal to 0.80. Oops. Pause for a second. Okay. Assuming that groups of 800 grand jurors are randomly selected. So 800 is going to be our N. So N is 800. Assuming that groups of 800 grand jurors are randomly selected, Find the mean and the standard deviation for the number of Mexican Americans. Okay, this is a binomial problem because either you're Mexican American or you are not. And so you would go to the Chapter 5 box, and right in the middle of the box is the formula for the mean of a binomial and the standard deviation of a binomial. So the mean mu is equal to n times p. So that would be 800. I'm trying to see how I'm going to line this up. Okay. I have to